Hello everyone, welcome back to CS Concepts. Today we are going to learn one of the most important DSA techniques called the sliding window technique. Before we implement it, let's first understand what it is. It is an optimization technique mainly used with arrays and strings. Whenever a problem asks us to find something in a group of consecutive elements such as maximum sum of k consecutive elements and minimum sum of k consecutive elements, average of k consecutive elements, and many similar problems, the sliding window technique can help us solve the problem efficiently. Now, why is it called a sliding window? Imagine a window placed over an array. Initially, the window covers a fixed number of elements. Then the window moves one position to the right. Again, it moves one position to the right. So the window keeps sliding through the array. That's why it is called the sliding window technique. So the main advantage of this technique is that we avoid repeating calculations. So instead of calculating everything again, whenever the window moves, we reuse the previous result. In simple words, one element leaves the window and one new element enters the window. So we remove one element and add one element. Now let's understand this using an example. So first let's create an array. Array name, let it be ARR. And the elements, let's take 5 elements. Okay. So this array contains 5 elements. Next, let's define the window size. So the window size, let it be k is equal to 3. Here k represents the window size. This means our window can contain only 3 consecutive elements at a time. Our goal is to find maximum sum among all windows of size 3. Before writing the logic, let's understand the windows. So the first window is 5, 2, minus 1. The second window is 2 minus 1, 0. And the third window is minus 1, 0, 3. So, if we calculate the sum of every window separately, it works. But for a very large array, repeatedly calculating every window sum becomes inefficient. So, instead of recalculating everything, we will use the sliding window technique. Now, let's start the implementation. Okay, first we need the sum of the first window. For that, we'll create a variable called window sum. Okay, then let's understand this carefully. Here, window sum is a variable. Okay, and this here sum is a built-in Python function. So its job is to add all the elements in a list. And what is this? This is the slicing operation. A slicing operation is used to extract a portion of an array or list. Here k is 3, right? So let's see the index. So what happens? This slicing operation, it starts from index 0 and stops before index 3. So Python takes 5 to minus 1. Okay. So this sum functions adds these values, which gives 6. Therefore, window sum will be 6. Next, we create another variable, that is max sum is equal to window sum. So here, why do we need this variable maximum? Our goal is to find the maximum window sum. So at this moment, we have calculated only one window sum. So the first window sum is currently the maximum value we know. Therefore, we store it in maximum. So at this point, maximum is equal to 6. Okay. Next, we need a loop to move the window through the array. For loop. Okay, let's understand this. We all know that for is used for iteration. Iteration means repeating a set of instructions multiple times. Here I is called the loop variable. Its value changes automatically during each iteration. Now let's understand range. Inside range we have a length. It's a built-in Python function. It returns the total number of elements in the array. So for our array, the length is 5. Since k is 3, Python sees range 3 comma 5. Okay, so which generates 3 and 4. So there will be only 2 iterations. And why are we starting from 3? I mean the range. Because indices 0, we can see here, indices 0, 1 and 2 have already been used in the first window. So the next unseen element is at index 3. Okay, so that's why the loop starts from k. And now comes the most important part of the sliding window technique. Let's see what is that. Window sum is equal to window sum minus ARR of I minus k. So this line removes the outgoing element. Let's understand the thinking. So let me write the array here again for your understanding. Our array is 5, 2, minus 1, 0 and 3, right? Okay. So our first window, for our first window, the elements are 5, 2, minus 1. Okay. So when the window, I mean for 3 consecutive elements, we are finding for 3 consecutive elements, right? So it is 5, 2, minus 1 and we got the first window sum as 6. Okay. Now when the window moves one step to the right, one element leaves the window. So which is that element? Here it is 5. Okay. So this 5 leaves the window. So we must remove that element's contribution from the current sum. So that is exactly what this line of code does. Okay. Fine. Now the next line. Now the next line of the code, window sum is equal to window sum plus ARR of I. Okay, so this line adds the incoming element. When the window moves, a new element enters the window. In the previous line, I told you that one element will leave the window, and here in the next line of the code, we are adding the incoming element. So for the next window, we will get the elements. We will have the elements like 2, minus 1 and 0. So which is the new element here? 0. Okay. So we add that element to the current sum. So now our new window sum is ready. Let's substitute the values for the first iteration. Okay, look at the for loop. We have 2 iterations. For the first iteration, I value is 3. Okay. So the current window, I mean the first window is 5, 2, minus 1. And the next window is 2, minus 1, 0. As I said earlier, the outgoing element is 5 and the incoming element is 0. Okay. Now let's substitute the values here. Inside the for loop, we have this line of code and this. Okay. So this line of code is for removing the outgoing element and this line of code is for adding the incoming element. Okay, now let's substitute. We all know that the value for window sum is 6. Okay, so 6 minus ARR of I minus k, what is it? 3 minus 3. I current value is 3, right? So 3 minus 3 and k value is 3. So ARR of 0. What is there in ARR of 0? I mean the index 0. What is that? 5. So 6 minus 5 is equal to 1. So window sum is 1 now, and let's substitute this value over here. So 1 plus, what is I current value? 3, right? So index 0, 1, 2, 3. What is there in 3? 0. So 1 plus 0 is equal to 1. So the new window sum now it is 1. Okay. Now we have to compare it with the maximum sum. Do you remember maximum sum? We stored the first window sum value in maximum sum, right? So the maximum sum value is 6 already. Let's see how to compare it here. Max sum is equal to okay. So here in this line of code, max, it is a built-in Python function. It compares two values and returns the larger one. Here Python checks. So we all know that max sum value is 6 and new window sum value 1. Sorry, it's 1. Okay. So which is larger? 6, right? So max sum is equal to 6. Okay. Now let's move on to the second iteration. So I value is 4. Before this iteration, our current window is 2 minus 1, 0, and the current window sum is 1. Okay, now the window moves one position to the right, so the new window becomes minus 1, 0, 3. Again, let's identify the outgoing and incoming elements. The outgoing element is 2 and the incoming element is 3. Okay, so because it is entering the new window. Now let's execute the first line inside the for loop. We have to substitute the values. I'll write it here separately because it's a bit confusing when I substitute it again over there. So window sum is equal to, what is the window sum here? 1. So window sum is equal to window sum minus ARR of I minus k. What is the value for I? It is 4 and k is 3. So 4 minus 3. So what we will get is 1 minus ARR of 1. What is there in ARR of 1? Let's see. Let's see the array. In ARR of 1, we have 2, right? Okay. So 1 minus 2. So what we will get the window sum as minus 1. Okay. So the window sum value is minus 1. At this point, we have removed the outgoing element. Now let's execute the second line. So the second line is what? Window sum is equal to, we are adding the incoming element. Okay. Window sum is equal to window sum plus AR of I. Let's substitute. So the window sum value is minus 1, right? Okay. Minus 1 plus AR of 4. I value is 4. So ARR of 4. So we have minus 1 plus, what is there in ARR of 4? We have 3. Okay. So minus 1 plus 3, which gives 2. So window sum is 2 now. Next, we will compare it with the maximum sum. We can see, right, window sum is 2, but maximum sum is, we know that it is 6. So when we compare 6 comma 2, I mean the new value window sum 2, when we compare it, again we will get 6 as output. Okay, so that's all. So no update is needed because the current window sum is smaller than the maximum sum. Now the loop is finished because there are no more values for I. So finally we print the maximum sum. So we will use print max sum. So the output is 6. So among all the windows, 5 comma 2 comma minus 1, I mean for the first 5 2 minus 1, this is the first window, and the second one is 2 minus 1 0, we got 6, sorry 1, and for the third, I mean the last window, we got 2. Okay, so the maximum sum is 6. So notice that we never recalculated the entire window sum. We simply removed the outgoing element and added the incoming element. That is the power of sliding window technique.